In this question, we're asked to solve for theta between 0 and 2 pi. Sine 2 theta plus cos 2 theta plus 1 is equal to root 6 cos theta, given our answers in terms of pi. As with all of these trig questions, there's lots of different approaches you can take. What I'm going to do is rewrite now double angle identities. So if I start here, I've got cos 2 theta. So I can write cos 2 theta can be written as 2 cos squared theta minus 1. Therefore, we can say cos 2 theta plus 1 will be 2 cos squared theta. So substituting straight in, I can say sine 2 theta, which I'll deal with shortly, plus 2 cos squared theta will be equal now to root 6 cos theta. So using a second double angle identity for sine, we can say sine 2 theta is 2 sine theta cos theta. If I substitute that in, we've got 2 sine theta cos theta plus 2 cos squared theta, and I'm just going to subtract this from both sides, minus root 6 cos theta is equal to 0. We can see here that we've got a common factor of cos theta, so let's go ahead and factor that. We've got cos theta. I'm going to have 2 sine theta plus 2 cos theta minus root 6 is equal to 0. So let's consider the two scenarios here. If I just rewrite this, we can say now that cos theta would be equal to 0, which is nice and straightforward to deal with, or the quantity of this bracket now here is going to be equal to 0. So I'm going to consider this scenario, and I'm also going to consider the scenario, and just rewriting this slightly, I'm going to write this as cos theta plus sine theta will be equal to root 6 over 2. So all I'm doing now is rewriting this, and we'll deal with this one shortly. This is the easier one to deal with, so let's go ahead and do that. You can of course do this by recognition, or you can simply sketch up the graph to find your points. So what we've got then is cosine theta, we come down to the minimum and then back up to the maximum. It looks something like so. So we want to know where it's equal now to 0. We've got pi by 2, and then by symmetry we're going to have 3 pi by 2. So we can say if cos theta is equal to 0, let's just write this here, cos theta is equal to 0, therefore we can say that theta is equal to pi by 2 and then 3 pi by 2. So they are two of our solutions. Let's go ahead and deal with this. Now you might be able to spot and factor this straight off. If not, you can use r cos of theta minus alpha or r sine of theta plus alpha. What I'm going to do is use r cos of theta minus alpha. If you want to go ahead and factor it straight off, you're welcome to do so. I'm just going to go through this method as it's not always easy to spot. So if we have now r cos theta cos alpha, and then we're going to have plus r sine theta sine alpha. So from this we can see that r cos alpha is going to be equal now to 1. We've got r sine alpha, and that will also be equal to 1. Therefore, finding our value of r, we can write therefore r will be the square root of 1 squared plus 1 squared. So we've got r is equal to root 2. If we now look at alpha, we find alpha by simply dividing r sine alpha by r cos alpha. That will give us tan alpha is equal to 1 over 1, which is 1. We can say therefore alpha, which is an acute angle, will be pi by 4. So I can rewrite this now, and I can write this in the form root 2 cos of theta minus pi by 4 is equal now to the value right here, which is root 6 over 2. So let's go ahead and deal with this. If I divide both sides by root 2, I'm just going to rewrite this. We've got cos of theta minus the pi by 4. And I'm just going to rewrite this so we can see this cancelling off. We can have the root of 2 multiplied by the root of 3 over now the root of 2 multiplied by 2. So we can see that these are going to cancel, and we can write now that cos of theta minus the pi by 4 will be equal now to the root 3 over 2. Now we're interested in this from 0 to 2 pi. So we want theta from 0 to 2 pi. If we now consider this right here, what we're going to have is the following. This is one of our exact values. So if I take the inverse cosine now of root 3 over 2, I'm going to have theta minus pi by 4 will be equal now to our principal value, which is going to be pi by 6. If we consider the symmetry now, we're going to have the next one, which is going to be theta minus pi by 4, will be pi by 6 back from 2 pi. And that's 5 pi by 6. This one is going to be no good, because once I add the pi by 4, we're going to go outside the interval. So all I need to do is consider now theta minus pi by 4 will be equal to minus pi by 6. If we just look at the symmetry, or alternatively, you can cycle this back by 2 pi. We've got 1 just here, and these are our principal values, and these aren't massively accurate. These are our principal values now for the quantity theta minus pi by 4. So this is what I'm interested in. I'm interested in these two and these two only. So all we've got to do now is add the pi by 4 to both sides. So what I'm going to have, and I'll just write it out here, and I'll put these in terms of 12. So we're going to have theta minus 3 pi by 12 will be equal now to minus 2 pi by 12. So if I add now 3 pi by 12 to both sides, I'm going to get theta is equal to pi by 12. That will be my first, and then if we just consider the next one we've got here, we've got theta minus, and that will be 3 pi by 12 will be equal now to positive 2 pi by 12. So we can say now that this will give us theta is going to be 5 pi by 12. So lots of different ways that you could find those two values. It's entirely up to you. I mean, you may want to find this one right here and subtract 2 pi, or you just might want to consider the symmetry. It's entirely up to you with that question. So what we're going to have then are our values. We're going to have the following. We've got now our pi by 12, so that's going to be the smallest. So we can say theta is going to be pi by 12. And then the next one we've got here, we've got 5 pi by 12. So let's look at that. And what else have we got? Pi by 2 and then 3 pi by 2. So we've got pi by 12, we've got 5 pi by 12, we've got pi by 2, and then we've finally got now 3 pi by 2. So 4 solutions in the interval, and it's entirely up to you at this stage where you get those from. When I did the r cos of theta minus alpha, you might not need that. You might recognise that factor straight off to give us the root 2, and then we'd have the cos of theta minus pi by 4. Alternatively, of course, you could have used sine and gone exactly the other way, but simply had now the positive value in there and solved from it. So there we go, 4 solutions to that particular equation.